Alright, here is my last video. This is my second video for assessment number 11 on equilibrium. What we have is we have a 65 kilogram painter that is standing on a support. The board that she's standing on weighs 15 kilograms, and we want to find how the force of the two supports right here. What we do know is that each support is located 2 meters from the board. The painter is 2 meters from the support, and altogether from one support to the next is a total of 8 meters. What I first did was I drew a free body diagram. We know that the supports are causing an upward force on both ends of the board, and that the painter, the board and the painter are having a downward force. What we first had to do, we were given the kilograms of the mass of the board and the mass of the person, so I went ahead and I calculated the force that they were causing. So force equals mass times gravity, so 65 times 9.8, because the painter exerts a force of 637 newtons, and the same thing with the board. The board produces a force of 147 newtons. We then, to find the force of the supports, I first looked at if we have our forces all equal to 0, so F net equals 0. In the y direction, we have N1 minus the mass of the board minus the mass of the person. I guess these should be forces. Minus the force of the person minus the force of the board, plus the normal force of the second support equals to 0. However, we are trying to find the force of both supports, and since we have two unknowns, it means that we have to have a certain another equation. So we use the torque equals 0 equation, and what I did was I chose to put my pivot point around the force of the second support. So what we know is that the torques in both directions have to equal each other. So we know that the torque of the board and the torque of the person move in the same direction, and that these two torques together have to equal the torque of the first support. So I broke this down further, and we know that torque is the force times the radius. So we have force of the board times the radius of the board equal plus the force of the person times the radius of the person equals the force of the first support times the radius of the first support. And then I just solved it all for N1, and we get torque of the board plus the torque of the person, and then divided by the radius of the first normal force. To find the radius of each of the forces, you have to look back at the free body diagram, but we automatically know that I have these mixed up. The person is standing 2 meters from our pivot point. You can look back and see that. And then we know that the force of the board has to be in the center of the distance between the two support systems. So we know that together, if you look back, that the in between both supports was a total of 8 meters. 8 divided by 2 gives us 4 meters. And then altogether, it was, you divided the radius of the N2 is 8 meters from N1. And we get that N1 is 355 newtons. All you do now is you plug your what you got for N1 into your original equation to find the force of N2, And when you add everything together, subtract it out, you get that the force of N2 is 429 newtons. Like I said, this is assessment number 11.